So, ladies and gentlemen, well, for our final session, which is the keynote on cloud and AI, the new recipe for a technological revolution, we're now joined by Angela Kim, Head of Analytics and AI, Teachers Health Fund. Well, Angela is an AI professional specialized in ethics, explainability, diversity, and inclusion in AI, and a recipient of Top 10 Analytic Leaders 2020 from the Institute of Analytics Professional Australia. She also sits on the founding editorial board of Springer's new and timely AI and Ethics Journal. Thank you so much, Angela, for now joining us at the World AI Show. It's a pleasure having you. With this, I introduce you to the stage and screen. Thank you, Angela, for joining us today.
Lovely, thank you. Always pleasure. Thank you. Thanks for having me. Hi, everyone. Well, welcome to TrustCon AI World AI Show, and it's such a pleasure for me to join today to share about AI and cloud. So let me share the screen with you. So you can see that there's people generally when people ask about AI and cloud, the relationship, most often people can get the idea why cloud computing is related to AI. But today I'd like to take you through a few key points that really plays fundamental foundation block, and also the application of AI and how that's related to cloud and cloud computing. So let me start with key cloud characteristics. The main goal of cloud computing is to allow IT resources to actually delivered and consumed as a service. So as you can see that there's scalability and electricity. Massive scalability and rapid electricity includes compute, storage, and network capacity, and also pooling. So pooling of shared resources, networks and servers and storage and applications requires multi-tenancy model, and measured service or pay as you go only for what is needed, on demand and self-service. So increase or decrease resources as needed, provision without requiring human interaction with the service provider. The second last point is network capabilities assessed over the network, and CapEx to OpEx. Capital expenditure is often converted to operational expenditure. So what does that mean to us? So I'd like to take on to the history of AI and cloud computing. So references to the phrase cloud computing appeared as early as 1996. So with the first known mention in compact internal document. So the term cloud was introduced even before 1993, but modern cloud computing was created and popularized by Amazon in 2006 with the Elastic Compute Cloud Service. The first cloud delivery model was the infrastructure as a service to provide prepackaged IT resources to users, and software as a service were introduced. All these delivery models were used for different workloads, including AI workloads. And you can see that, when you, talk about cloud deployment models, there are public, private, and hybrid. So these deployment models are also important to look at AI workload based on functional and non-functional requirements and constraints. So according to the World Economic Forum's The Future of Jobs report, cloud computing is the highest priority of business leaders. And until 2025, cloud computing will be adopted the most by companies. Though artificial intelligence started much earlier than cloud computing and its technologies have improved AI very much. Cloud computing has been an effective catalyst, so to speak. As you can see on your right-hand side, where I'm looking at, you can see that, at a glance, how data, processing capability, models and algorithms and talent skills and artificial intelligence, it is an ecosystem for cloud and computing. So let's have a look at, decadal perspectives on the impact of AI. As you can see that 2010, Apple acquires Siri, the AI voice assistant, and Microsoft launches Kinect for Xbox 360. 2021, IBM Watson wins at Jeopardy, defeating two former champions. And 2013, and NEIL, Never-Ending Image Learner, is a computer program created to learn information about online images and common sense relationships. And 2015, you can see that Google's open source deep learning framework, TensorFlow, is released. In 2016, Google demands AlphaGo beat world champion Lee Sedol at computer programming Go 4 out of 5 times. In 2017, 2 chatbots are trained by Facebook AI Research Lab to learn how to negotiate and speak. 2018, Waymo, the company owned by Alphabet Inc., that is attempting to create a fully autonomous vehicle, reaches 10 million self-driven miles. 2019, deepfake detection challenge begins with the help of AWS, BBC News, CBC News, Facebook, First Draft, Microsoft, the New York Times, Witness, and X Prize. So as you can see that it's not surprising that actually you can see that how AI and cloud computing they are really you can't separate them, and because they go hand in hand. So when you talk about cloud computing, services has morphed from platforms such as Google App Engine and Azure to infrastructure, which involves the provision of machines for computing and storage. In addition to this, cloud providers also offer data platform services, which span the different available databases. This chain of development points in the direction of the growth of artificial intelligence and cloud computing. What is artificial intelligence then? AI, popularly referred to artificial intelligence, which is referred as AI, refers to the simulated intelligence in machines. The term refers to the end result of endowing machines with an intellectual process peculiar to humans, the ability to reason, learn, and from the past, discover meaning or generalize. So when you talk about cloud computing, there are existing types of clouding application development services. I have lightly touched on previous slide, but this one really gives you a bit of detail about infrastructure as a service and platform as a service and software as a service, which is very fundamental on the backbone when you talk about cloud computing application. So infrastructure as a service is a cloud app development service which is mostly employed by users. It allows you to pay based on the users of the service provided and flexible plan. So platform as a service, this was designed to make web creation and mobile app design easier to have built infrastructure of servers, networks, databases, and storage that eliminates the need to constantly update them or manage them. Software as a service is cloud provider, not the user is tasked with management and maintenance, or all the user has to do to gain access is connected to the application over the internet with a web browser or phone, tablet, or PC. So type of cloud deployment, public cloud. So public clouds like Microsoft Azure, the cloud provider owns and manages all hardware, software, and other supporting infrastructures and responsible for delivering computing resources, servers, storage over the internet. As a user, you can gain access to these services and manage your account through the web browser. So when you talk about the private cloud, just as the name implies, private cloud service and infrastructure are maintained on a private network either by the providing company or hired third-party service provider. Hybrid cloud, as the name indicates, is both the public and the private cloud services. And how the model is possible? It is made available by the integration of the personalized data and application shared by the both platforms. Clients looking for more flexible cloud app development solution and a wide range of deployment options advised to embrace this technology. So when you talk about all this infrastructure for cloud computing, this is really to do with machine learning. So machine learning models, when at large scale, the data set is applied, it applied to certain algorithms, and it becomes important to leverage the cloud for this. The models are able to learn from the different patterns, which are gleaned from the available data. So if I have to, I can show from the example how it can be generated from the diagram. I'll show you from this slide. So as you can see that when I talked about how the model generated, and when you ingest the data from data ingestion stage, by the way, this example is the one we deployed at work in a Databricks environment. And you can see that how the cloud computing plays a really pivotal role, because you can see that, data lake enables, and it really comes together how it's, data can be ingested, and and in the production environment, how data can be scored, and in the analyst factory environment, actually the machine learning is actually run and score almost real time. And this can be cyclical, and this can be done all completely end to end seamlessly. So as you can see that the power of cloud and computing actually enables the machine learning model, and which is a crucial part when you talk about AI and AI and cloud computing. And also we have to talk about benefits of leveraging AI and cloud computing, cost effectiveness. So by being accessible through the internet, the cloud application development eliminates the need for expenses on site hardware and software and purchases and setup. It also eliminates the need on site data centers and the expenses that comes with it. IT experts to manage the center servers and round the clock electricity to power and cool the servers. So as you can see that AI and cloud computing is really empowered by and providing all these benefits, which are increased productivity. Unlike a hard drive or local storage device, which requires a lot of IT management chores. Hardware setup, software patching, racking, and stacking. Cloud compute is all internet-based, and as such, has no need for this. This gives room for the IT team to focus on achieving other business goals. Reliability with hard drive or physically accessible infrastructures. The risk of damage is heightened. So one faces the risk of the crash, lost files, backup failure, and so much more. However, cloud computing solutions ensure business continuity, faster and easier disaster recovery, and easier data backup. Availability of advanced infrastructure. AI applications are generally high performance when on servers with multiple and very fast graphics processing units, GPUs. These systems are, however, extremely expensive and unaffordable for many organizations. AI as a service in cloud application development becomes accessible to these organizations at a more affordable price. Conclusion: we strongly believe that the fusion of cloud computing services and AI technology will bring a significant change in the technology industry. Public cloud providers keep on investing in the growth of AI, and this will continue to attract the right set of clients to this technology. Even though the technology is still in its early stage, the evolution to come is inevitable, and we can expect phenomenal advancements in the future. I'd like to show, kind of infrastructures of the typical the business environment. How, for example, when you have all the data sources and data platform, and how you're, this is hybrid model, as you can see that, data lake. That's where all this cloud computing is happening, and it can consume unstructured, streamed, and structured data in different formats, and it can ingest all these internal data sources, external sources, and real-time data, and supplementary sources as well. In a consumption layer, it enables for smooth and seamless reporting and dashboard. And that really enables the capability of analytics programs, which can create benefit and cost efficiencies for the business and the customers as well. You can see that there are some the user cases I've mentioned. I'd like to highlight on all these different data points, and how the organization grow, they collect more data, and nowadays the accumulation of data is unimaginable. You even bring in all this image data, and the processing the component becomes really important, and that's why it's almost indispensable that you need to really adopt this new way of the using the cloudy environment for especially for model building and machine learning model deployment. So as you can see that data exploration and collection can be happening in the legacy in the on-premise environment. Even data profiling and quality volume can be all happening there. And from the moment where data transformation and feature engineering and model classification and model tuning, all these process has to be done in typically in the cloud computing environment, because the real time and continuous scoring the machine learning model through the algorithm and the fine tuning and all this seamless, the process has to be done in a very efficient manner. And that's why, again, all this typical, for this typical example was the Azure environment, but in data lake and data ingestion and Azure Data Factory consuming and all this model scoring is happening in real-time analyst factory. So this is all end-to-end journey of AI model deployment, and this is happening in cloud environment. Thank you so much for the opportunity for me to share this insights and about what's happening in AI and cloud environment. And I hope you enjoyed my talk. If there's any further questions, please reach out to me to LinkedIn, Angela Kim, please. Thank you.
Thank you so much, Angela, for that wonderful.